next section, 10.3, Parametric equation and calculus. Let's look at the first theorem first. Theorem 10.7, parametric form of derivative. If a smooth curve C, you have a curve C is given by the equation x equal to f of t. Think about position x at particular time t and y equal to g of t. Think of particular position of y at time t. Then the slope of c. Slope of c at xy is derivative dy dx is equal to dy dt divided by dx dt, where dx dt cannot be 0 because we don't want the denominator to be 0. So what it says is that you have this first equation, t and x. You have second equation, variable t and y. You take the first derivative, dy with respect to t, and then dx with respect to t. So let's look at our example. Parametric equation, x equal to t squared plus 5t plus 4, y equal to 4t. Now they ask you to find slope. Find slope, again we're going to take the first derivative. So we're going to use this formula here, the first formula that I give it to you. So is dy dx is equal to dy dt divided by dx dt. So dy dt is mean derivative of y with respect to t. So you go here. You take derivative of this with respect to t. So you're going to have 4. On the denominator, dx dt, derivative of x with respect to t, then you go here. You're going to have 2t plus 5. Remember, this is dy dt. This is the slope of c at xy at particular time. The question, they want you to find the slope at time t. So I'm going to put t equal to 0. So substitute 0 for t. Then I have 4 over 5. It means the slope at time t is 4 over 5. Now the next question, they ask for concavity. Concavity, usually we take second derivative. Now second derivative, this is the formula. I'm just going to go straight to here. So you take derivative of this, dy dx, which you get it from the first step. Dy dx is come from the first step. You take derivative of this with respect to t. And then on the denominator, you take derivative of x with respect to t. So that's what I'm going to do. So second derivative will be the d dt of dy dx. This is my dy dx. Alright? Now, dx dt, again, derivative with respect to t of this one. It will be 2t plus 5. The denominator, I don't have to do anything. Now I'm going to take derivative of this with respect to t. I'm going to rewrite it as 4 times 2t plus 5 to the negative 1. Then take derivative of this, I'm going to have negative 4, 2t plus 5, negative 1 minus 1 is negative 2. Derivative inside is just 2. And then I multiply negative 4 and 2, which is negative 8. 2t plus 5 to the negative 2, if you bring it to the denominator, it's going to be 2t plus 5 to second power. This is first power plus second power is third power. Again, they want to know at time t, what is the concavity at time t. So I have to substitute 0 for t. Then I substitute 0 for t, I end up negative 8 over 125, which is negative. So we know it's concave downward. Alright, let's see the next example. Hi everyone, let's look at our next example. This example, the Paulet cycloid giving this equation, x equal to 2t minus pi sine t. And y equal to 2 minus pi cosine of t. So this is the graph is given. Alright, so you have, they ask you to find the equation of the tangent line at 0, 2. 0, 2 is over here. This is point x is 0 and y is 2. So you have two tangent lines, one going down and one going up. So the one going down, the slope should be negative. The one going up, the slope should be positive. And the tangent line or equation of the line is y equal y1, y minus y1 equal mx minus x1. So I have a coordinate here 0, 2. So I have my x and my y, but I'm missing the slope. Again, the slope, from the previous example or definition, the slope you can get is from dy dx, or another word, you take derivative of y with respect to t on the numerator and take derivative of x with respect to t on the denominator. So let's take derivative of y with respect to t, which is this one. Derivative of 2 is just 0. Derivative of pi cosine of t is just pi sine of t. Now on the denominator is derivative of x with respect to t. So 2t, you just have 2 minus pi sine of t. You're going to have minus pi cosine of t. Now the problem is we don't know what t here. This is an angle here, an angle of sine and cosine. But we know x is 0 and y is 2. So what I'm going to do, I'm going to substitute 0 here. Alright, x is 0. Sorry, 0. So I'm going to solve for t, figure out what t is. So 0, 2t minus pi sine t. So to make it equal to 0, t has to be either plus or minus pi over 2 to make this whole thing equal to 0. Same idea, I have y equal to 2 minus pi cosine t at point 0 t. So I substitute y equal to 2 and then move things around a little bit. So pi cosine of t equal to 0. To make this equation satisfy, t has to be plus or minus pi over 2. So this is my t right for here. So I substitute t plus or minus pi over 2 in this slope function here. So as you can see, then if I substitute minus pi over 2, I have pi sine negative pi over 2 minus pi cosine negative pi over 2. Sine negative pi over 2 is negative 1, so you have negative pi. Cosine of negative pi over 2 is 0, so the second term is 0, so you end up with negative pi over 2. If you substitute pi over 2 in here, this is what you have. Sine of pi over 2 is 1, that's why you have pi. 2 is 2. Cosine of pi over 2 is 0, so the second term is 0. So you end up with pi over 2. So this is the slope. Alright, this is the slope. One is negative as I mentioned, and one is positive. Then you put in a point 0, 2 for the slope is positive, pi over 2. This is equation of the line of this one. That's the equation of the tangent line of this one. If you substitute negative pi over 2 at point 0, 2, you have y equal to 2 minus pi over 2x. This is the equation of the tangent line of this one. Alright, let's look at the next example. Hi everyone, let's look at the next example. Find the arc's length of the curve on the interval t greater than or equal to 0, less than or equal to 4. Giving the parametric equation, x is equal to 6t squared, y is equal to 2t to the cube. And this is the formula to find out length, alright? So the formula said you take an integral from a to b. So my a would be 1, my b would be 4. So I have an integral from 1 to 4. dx dt is mean derivative of x with respect to t. So if you take derivative of x with respect to t, you will have 12t. So I have 12t squared because the formula says square. dy dt, it will be 6t squared. So I have 6t squared, quantity squared. The next step that I did is I squared. So I would have 144t squared plus 36t to the fourth dt. The next step I do is I factor out 36t squared because this is a perfect square. I want to take it out. which I take it out over here, which is 6t. Everything else remain the same. Next step I did is, instead of radical, I write it as exponential term, which is 1/2. Now I try to use this formula in integral of u to the n du is equal to u n plus 1 over n plus 1 plus c. So my u here would be 4 plus t squared, and my du would be 2t dt. So I have 6t here. I want 2t. That's why I take out the 3, because I wanted 2t, but I have 6t. So I took out the 3. I end up with 2t. So it's fit the perfect, the formula perfectly. 2t dt, which is my du, and my u raised to the n power. I'm using this formula here. I leave the 3 alone, so I'm going to have u n plus 1. I have 1/2 already, plus 2 over 2 is going to be 3 over 2. Divide by 3 over 2. I simplify the 3, and then I have 2. And then my lower bound is 1, my upper bound is 4. I substitute 4 for t. I have 16. I substitute 1 for t here, I get 1. And then I just use calculator to simplify it. It's turned out to be 156.52. So this will be an arc length of a curve. Right, let's look at the next example. Hi everyone, let's look at our last section of theorem 10.9. Area of the first surface of revolution. I don't have enough room to write the complete theorem, so you might want to read it in the book. But it said that if you have x equal to f of t and y equal to g of t, the revolution about the x-axis, this is the area of the surface revolution. That's the formula. And the revolution about the y-axis, and this is the formula. Let's look at the example. Find the area of the surface generated by revolving the curve about the y and the x-axis, given x equal to t and y equal to 4 minus 2t. T is between 0, including 0, and 2, including 2. So I'm going to find the revolution about the x-axis. So what we just substitute in the formula here. So this is the formula. So I have s equal to 2 pi, and integral, my a is 0, my b is 2. So an integral from 0 to t. G of t is the y. Remember, if you revolution about x-axis, you're going to use y. Alright, you're going to use y. So my y here is 4 minus 2t. Square root dt, dx dt, derivative of x with respect to t. So derivative of x with respect to t is just 1, so 1 square, plus derivative of y with respect to t. Derivative of y with respect to t is -2, so -2 square. So I'm going to have 2 pi, an integral from 0 to 2, 4 minus 2t. This 2, 1 and 4 is just square root of 5. I bring out square root of 5, so I'll add with t, 4 and 2t. An integral of 4 is 4t, and integral of -2t is -t squared. And then the lower bound is 0, the upper bound is 2. It's pretty simple. If you do that, you're going to get 8 square root of 5 pi. For the revolution about the y-axis, I'm going to use this formula, right? So an integral, s is 2 pi, an integral, my a is still 0, my b is still 2, f of t. Now, remember revolution about the y-axis, f of t is going to be x. It's going to be your x. So my x is t. And then this term is the same that we already calculated, is square root of 5. I bring it out. An integral of t is just t squared over 2. Lower bound is 0, upper bound is 2. If you substitute it in, you should have 4 square root of 5 pi. Alright, we finished 10.3. I'll see you next time. Bye.